Hello, good morning, everybody. Today we are going to learn on how to graph rational functions. Our memory verse today is found in Ephesians 2, verse 19. It says, "So then you are no longer strangers and aliens, but members of the household of God." In this lesson, we'll be learning how to graph rational functions. Actually, this is a continuation of our previous lesson on solving rational functions. So to start with, here's your venture with me. You need to check the graphs below and mark with a smiley face the graph that represents rational functions. You could pause this video and do your venture with me activity. How to graph rational functions. Here are 8 simple steps for you to follow. Step number 1. You need to draw the rectangular coordinate plane. It will be better if you have a graphing paper so that you could draw it easier. Second, you need to solve for the vertical and horizontal asymptotes. Third, you need to draw the asymptotes in the rectangular coordinate plane. Not coordinated, it's coordinate plane. Number 4, solve for the x and y intercepts of the function. Number 5, plot the x and y intercepts in the graph or a hole if there is any. And 6, make a table of values. Where do we base it? We base it on the vertical asymptote. We need to have at least 2 points to the left of the vertical asymptote and 2 points to the right of the vertical asymptote. And if there are 2 vertical asymptotes, we need to plot at least 5 points in the middle of 2 vertical asymptotes. And after making your table of values, you go to number 7. You plot the points in the graph. Then draw the branches of the graph and be sure that the branches do not touch the asymptotes. And the last one, determine the domain and range of the function. Remember that the domain and range of the function are very much related to our number 2, our vertical and horizontal asymptotes. So, shall we start now? Let's do example number 1. Example number 1, you'll sketch the graph of f of x equals 5x all over 2x minus 8. So first, we draw the rectangular coordinate plane. Second, we solve for the vertical and horizontal asymptotes. Remember that the vertical asymptote is based on the denominator. That is 2x minus 8 is equal to 0. We solve for the value of x. That's going to be 2x equals 8. Divide both sides by 2. So our vertical asymptote is at x equals 4. Next, we solve for the horizontal asymptote. How do we do it? We look at the degrees of the leading coefficients. In the numerator, the degree of the polynomial is 1. Denominator, the degree of polynomial is also 1. So since they are the same, then we need to use the numerical coefficients of the leading coefficients. So we have y equals 5 over 2. If you check it with our answer, it's y equals 5 over 2. Next, we draw the asymptotes. Remember, our asymptote is x equals positive 4. The other is y equals 5 over 2 or 2 and 1/2. Then we solve our intercepts. We'll go back. Our x-intercept is based on the numerator. That's 5x equals 0. Divide both by 5, so x equals 0. For our y-intercept, we base it on the constant terms. So what's our constant term? 0 for the numerator and -8 for our denominator. Using that one, we'll have 0 all over -8, which is equal to 0. Then we plot our x and y intercepts. It's found at the point of origin, 0, 0. In step number 6, we make our table of values. Remember, our vertical asymptote is x plus 4. So we plot two x values to the left. So what's to the left of x equals 4? It can be 1 or 3. Then 2 points to the right. That can be 5 and 10. And using our equation, what's our equation again? Here, that's 5x over 2x minus 8. We substitute the values of x, then we get the value of your y. This is now the value of your y. Then we plot these points in the graph. So we have this one. Be sure that the branches of the asymptotes do not touch the vertical and horizontal asymptotes. So the last step is the domain and range. First, since the vertical asymptote is x equals 4, then our domain will be all real numbers except 4. And since our horizontal asymptote is y equals 5/2, then our range is all real numbers except 5/2. That ends our first video.